Hello everybody, this is Chuck, and as I always say, I appreciate you wanting to spend some time with me in my shop. I haven't done a video in a while, and to be truthful, I've been depressed and I've been in a funk because of this. Primarily because of this, and we'll talk about this. So as Saturday morning, I was working on something else, trying to solve it, and I thought, what the hell, let's try to get a video out while I'm doing it. So for starters, this is the swivel base for the bottom of the small little vise. And I've shown in some videos, and maybe I'll click in some stuff off my phone here. But all I've got left to do to this bottom is to put in the degrees, numbers. I'm going to hold this up there, and you can see that I've put in the 1 degree marks, and I've put in every 10 degrees. And I've got that completed. That was fun, moving the index head 1 degree, 1 degree, 1 degree. But I did it, got it done. Got to thank Dean, my buddy from Air Cave Shop. He let me a scriber tip to use in the mill, and it worked out well. So I've been trying to come up with a way to stamp the numbers in, and I don't know if that's coming in focus or not, to be honest with you, and I'm sorry because my eyes are out of focus. But it said macro, so maybe it was there. So how am I going to stamp the numbers in this? Carl, my good buddy, lent me some number stamps, and I started off in that path. He'd also lent me a square to round, square, square with a round, half-inch round cylinder that'll hold the number stamps. Hold the number stamps, that way I can put it in the mill. The dividing head's at 45 degrees, so the plan was come down and pop these in. So I ended up 3D printing a couple of these. I don't know where the second one went. It's in my hand, Charlie. So the plan was to have it in this holder so that it goes past the PLA, and put it in my drill chuck. And I was using my Albrecht drill truck so I could hand loosen it because I'm going to have to change these out, and put it in the drill chuck and come down and then mill quill and just pop the numbers in that way. If I had to, I would tap on the top, but in trying it, it looked like it was going to work. Well, that was pretty good, Charlie, but it didn't work. What I came to find out is well, let's see, let me go back even a little step further. I worked on devising, well, let's see, let me flip gears, I'm going too fast here. So this wasn't working. Didn't feel good with it. Kind of working. So I 3D printed some rings that fit on top of this guy, where I had it, where I had a notch in it, where I was trying to 3D print, and my fusion skills are limited. Okay, so I was pretty proud. Actually, the first one I did turned out really nice. My computer shut off and I lost the file. So I had to go back and try to recreate it, and how the hell did I even draw it? I don't even remember. But anyway, long story short there. So what I came to find out, where I was headed, was that the little number on the end of the number stamps from the ones that I borrowed from Carl, when you lined them up on a block and looked at them, the numbers were not dead center of the 1/4 inch square. They varied. So now my alignment of trying to come down and stamp the number, right? Well, if that little number's moving, I can't get the alignment. And this whole just to put it in reference for you, this whole 45-degree flat, well, from the 10th markings or 10-degree markings, excuse me, I have 100 thousandths on that flat to try to put that little number there. So I tried, and the other thing is the number has to offset from the degree line. So you got 1, 10, 20, 30. So it can't be right underneath the degree line. So I'm babbling a lot here, and I hope you guys can say goodbye if you're tired of this already. So anyway, I've done some multiple tries, and as I said, I became depressed. I was frustrated. I couldn't complete it. So I bought another set of number stamps myself, and I tested those, looking, measuring up on the surface plate. They're closer, but it's not dead center. So if you take out the 0 and put in the 2, it doesn't mean it's going to hit in the same spot. So where does that leave me, other than depressed? Well, I'm going to put it back in the indexer and take a nice little pass to erase whatever I've done so far. Just a very slight cut, and it won't affect anything. So I know I can do that. That's it. My next idea is I'm going to take the indexer off the mill, put it on my welding table where I can get a better look, put on the magnifiers of all time, somehow determine how I can hand do these and see what I'm doing and do it by hand one at a time. Getting it off the mill, I have more ability to try to visualize it, get better lighting. So that's where this guy lies. It's up my gin bill, I'll tell you that. Okay, so with that said, now let's go on to the next thing that I'm working on this morning. You can see right there, there's the hardness tester. I think it's in the view. Where'd it go? There it is. There's the hardness tester. And I have some video of trying to do some hardening, and we will switch over to that in a minute. Before I switch over, if you guys don't have a 3D printer, they're not that expensive. Try to learn Fusion. So this handheld hardness tester, that was a broom connection off of Thingiverse. 3D printed it, now it's handheld. I don't have to sit there and fight holding it and trying to hold the part. But I tell you, if you guys if you don't have a 3D printer, they're not that expensive, and boy, I can't tell you how they are great for prototyping. And we'll talk about that as we move on here. Okay, we're over here at the workbench, and as I was getting ready to go, I go, oh yeah, 3D printing. 3D printed this box. I mean, you can't beat it. Sorting trays, where you dump a lot of little small stuff in and you can find it. Vice jaws. Anyway, enough of that. So, I may have had some of this on an earlier video, but all of this paperwork here is for my good buddy Carl. And back in, there's a date on here someplace, 1278. He was drawing these items up. And there's all full-size drawings. There's a parts list that he was doing, everything. Well, somewhere in, here's at 08, he had written another whole list of things that he wanted to do, and one day I was over there and he says, you know something, I'm never going to finish this project. Do you want to do it? You can have it. Well, He gave that to me about 6 or 8 years ago. And finally the other day I decided, let's go. So the first thing I did is I 3D printed his drawings. So I 3D printed these guys to, one, practice my fusion skills, and then also to check his drawings and match his drawings, and 3D printed all these. And then the 3D print is what I would clamp to the piece of metal, scribe it out, and then go to the mill and cut it on the mill. Easy to do, you know, for layout. So interesting. The other day I was starting to store some of the parts in this little case. That's why it's here. And this thing arrived, and I think it's a money pouch. I don't know where it even came from. So turns out the complete puller set fits in here. Carl had made this unit, that was done, and Carl had finished this unit, that was completed. He had done those, and he had done the other fixture holder. He had completed that also. He had done centers. He had completed that. He had got that far. And get the rest of this out of the pouch. It's a nice little pouch that it fits. And come on. The lead screw is in here also. That's all. Carl had completed that also. And another one. Another thing. And he had also, where did I leave him? He had also, oh, I put him away. He had also, hey, let's say he had also machined these guys for locking the arms and the fixtures. Still needed to put the ball in it. They were all machined, knurled and everything, and I talked to Charlie, and Charlie says, hey, you know, these are very cheap on McMaster Car. So I ordered them from McMaster Car. So the units fit nice. Let's see, Charlie, put it the right way. Of course, when you're on camera, you know, forget it. You know they fit together, okay? That's not the purpose of this. It was a lot of work, a lot of fun. You can see I had to narrow them down to fit the fixture. Da-da-da. So what's the purpose of why we're over here right now? Heat treating. So you can see these were all glass beaded and clean. And these 3 units, I was attempting to harden these. It's 1050 steel, and there's not much documentation on how to harden 1050 steel because it's a low carbon steel. Don't quote me on that. Look it up. So Carl said I should harden them, and he said you could just harden the tips. And I said, well, I might as well just harden the whole thing. So they're going to flip to a video. I'll do a lot of fast forward of me using my oven. And you can see that these have been blued and hardened. Okay. Okay, we're back from that. Well, when I did hardness tests on these, think you can see the little dots. They weren't, I didn't get them hardened. They were no hardened, they were the same as a raw piece of material. I did find some literature on hardening, and it was 1600 degrees, and then you temper it 700. Well, interesting enough, when I did these, I was talking to Carl about it, and I says, yeah, it's just, you know, I cooked them in my oven at 1600 degrees for like an hour, and they didn't get hard. And he and he goes, did you check them with a magnet before you pulled them out and put them in the water? I went, no. See, I'm learning. So today, I've got a forge, and so I thought I'll just cheat on this and go quick. So I welded a piece of rebar to the end of this, put it in the forge, heated this guy so this whole front of this piece was red, checked it with a magnet. Magnet was not working, but of course the magnet would bite down here, but not down here. Said, okay, I've reached temperature, I cooled it. You can see the specs in my test piece here from the hardness tester, and it's up at almost 60 Rockwell, high 50s, where this is I think 35 when it's raw. So anyway, that's where I'm at. So I'm going to go back and redo all of these in the forge. I think I'm just, Carl's comment was I only needed to do the tips. I don't know about the tips on these. I guess they'll wear in the cup there. But so anyway, that's where I'm at. I'm going to go back and harden these guys and see what I get. The forge is going, and we will give it a go. Now it'd be interesting, this is the number 3, so I'm going to keep them separate. If the water temperature, of course, got warmer and warmer as I put these in, if it made any difference in the hardness. Don't know, something to mention. Okay, we'll bring you back. Okay, we're over here at the hardness tester, but I just tried it with the files, and quite, so this is a 55. Just skates on it, and if I come down to the other side, the 55 will scratch it. So definitely got some hardness. Let's, just for the fun of it, we'll go to 65. 65 will bite on the files. So let's see what the hardness tester tells us. I'm gonna have to get around you guys somehow. I gotta do it right-handed, so bear with me here. Let's see, can I see what the hell I'm doing? So you need to bring the dial to set. You bring the reader around, and then you go all the way to the 150. And then you come back to set. And that's showing me, I can't see it because you guys are in the way. That looks like at about 55. Looks like at about 55. So definitely got it hard. If we go down to the other side, bring the dial around. Come on, just a little bit more, baby. There you go. And we're down at about 35. So definitely a success on the hardening. So just took the arms out of the tempering oven, and then they went into an oil bath, and they get a nice oiled finish on them, which should prevent them from rusting, hopefully. Well, just a quick handheld to finish this project up. Here's all the puller parts there. Thought I'd throw some of the 3D prints so you can see how they match Carl's drawings. And like I said, Carl had done a lot of extensive work on this, along with getting these guys all built. The only thing he hadn't done was the jaws themselves, or the arms. Certainly wish I had something to try it on right now, but it'll get its turn.